According to most surveys of programming language popularity, JavaScript wins. Meanwhile, lots of people complain about how bad JavaScript is. So why is JavaScript the world's most popular programming language? Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel. If you haven't been here before, please do hit subscribe. And if you enjoy the content here today, hit like as well. The first version of JavaScript was written in 10 days in 1995 by Brendan Eich. Brendan worked for Netscape, producer of one of the first web browsers. Netscape wanted a scripting language for their browser, Netscape Navigator, to help people to write more interactive web pages. The genesis of JavaScript was a bit mixed. Brendan was hired to implement a version of the language Scheme initially in the browser, while alongside that Netscape did a deal with Sun Microsystems to implement Java as the browser scripting language. Fairly soon they asked Brendan to switch track and create a new language from scratch. 10 days later, JavaScript arrived. At the time, Java was the cool kid on the block, so JavaScript was named JavaScript to capitalize on Java's popularity rather than because of any strong similarity. There are some similarities, and these were intentional, but they don't really go very deep. Java is a statically typed object-oriented language that supports class-based inheritance and interface-based polymorphism. JavaScript has dynamic typing, prototype-based object orientation, and first-class functions. It's multi-paradigm, supporting event-driven functional and imperative programming styles. That's quite a lot of not always clearly aligned characteristics, to be honest. As a result, large JavaScript programs can often be a bit of a smorgasbord of patterns and techniques. Before I go any further, let me thank our sponsors. We're fortunate to be sponsored by Equal Experts, Tricentis, Transfic, Roost and Sleuth. All of these companies offer products and services that are very well aligned with the topics that we discuss on this channel here every week. So if you're looking for excellence in continuous delivery and software engineering, click on the links in the description below to check them out. Despite being that language smorgasbord, JavaScript was pretty innovative at the time that it was created. JavaScript predated CSS by a year, so when it was born, web pages were very different to today. They were straight HTML, and remember, HTML had been created only a few years earlier. So that was an awful lot simpler then than it is now too. HTML was designed to support hypertext, linked documents rather than code. Web pages were static things with links to other static web pages. If you wanted interactivity, you sent the page back to the server and you changed it there by generating a new web page on the fly. The most popular way to do that at the time was via something called CGI, which stood for Common Gateway Interface. We'd embed scripts in a web page, and when the browser hit the script, it would call the web server to process it. This was pretty slow, and there was a lot going on here if all you wanted to do was to handle a click or some simple validation. But it was how early steps in interactivity in a web page were handled. The idea that JavaScript enabled of being able to run programs in the browser itself was a pretty good one. It wasn't a new idea in general. People had been doing distributed programming of various kinds for quite a while, but it was new to the web. And while the web had not really exploded yet, it was kind of in the process of taking off. So JavaScript simplified a real programming problem. The creators standardized the language via ECMA relatively soon after the creation of the language. At the time of its creation, Netscape Navigator was the most popular web browser on the web. So you could say that JavaScript had a home field advantage at this point. But coming up fast was Microsoft with Internet Explorer. And Microsoft implemented their own version of the ECMA standard as JScript, a not perfectly compatible but close sibling of JavaScript. So now the two most popular browsers of the time each had a very similar scripting language based on a common standard, although they weren't compatible with one another. The other big idea that really made JavaScript a powerful tool in the browser was the creation of the DOM, the Document Object Model, as an API to provide access to browser content. The DOM evolved in parallel with JavaScript and opened the contents of a web page to easy manipulation by JavaScript code. Without the DOM, I'm not sure that JavaScript would have been such a big success, because without the DOM, or something similar anyway, any manipulations in the page would still not have been really dynamic, and so not really interactive. Actually, the first versions of the DOM weren't properly interactive either, but they were fairly quickly followed by versions that were, based on something that was called at the time dynamic HTML, which allowed the content of the pages to change and to update the display without reloading and reprocessing the whole page. This dynamism came later in 1997, but was an important step in liberating the real value of JavaScript, really. The history of software development is interesting and helps us to better understand not just the tools that we use like JavaScript, but importantly the broader context of their use. This helps us to make better decisions along the path towards better software, whatever the nature of the software that we're creating. Do check out my latest book, Modern Software Engineering, which describes those principles and how to apply them in more detail. At this point in the history of the web, there was a battle going on between Netscape and Microsoft. The browser war to try to establish at least de facto standards on the web that would force people to prefer one browser over the other. Their browsers and JavaScript and JScript had very similar features, but code for one did not give the same results as code in the other, and sometimes, often, simply didn't work at all. At this time, web pages often had banners saying this page works best with Internet Explorer or best with Netscape. Browser incompatibility was a big deal in the early days of web programming. By 2001, though, Microsoft had effectively won that first browser war, having 96% of the browser market with Internet Explorer in that year. One of the next big steps forward at this point, though, was the creation of jQuery, which did a lot to reduce the impact of browser incompatibilities, allowing web programmers to write code that would work whichever browser it landed on. One of the final technical steps, though, that liberated JavaScript as a fully fledged web page programming model was the introduction of Ajax. One of the problems with creating interactive web pages is that HTTP is a request-response protocol. At the level of HTTP, you send a request from a page and you get a response back to it. Remember, it was built for hypertext. The problem with this from a user's perspective is that they have to wait for the response back from the server. Ajax alleviated that by making the interaction with the user asynchronous and abstracting and hiding interactions with the server to some extent, allowing the user more freedom then to make progress even while a conversation with the server was taking place in the background. The other problem that Ajax addresses is what happens if something changes on the server and now the page is out of date. Ajax solved that by effectively opening a channel from the server to the page. Now we could send events to the page and build much more responsive feeling applications. One of the other advantages of JavaScript that both jQuery and Ajax demonstrate is that not only does JavaScript allow us to write apps that run on the page, it also allows us to write infrastructure that can run on the page. Ajax provides a layer of abstraction that isolates and manages interactions with the web server, and so provides a better experience for the programmer and for users. All of these things together were working towards something that I think was important: an effective, usable programming model for distributed computing on the web. The web was built to support hypertext, to link documents, to make it easier for people to explore information. But now it's much more than that. At the start, the request-response model for communications and the standardization of HTML allowed the hypertext model to flourish. A user did something on a page, a request was sent to a server, and the server responded with a new page. Then we started building applications on top of this hypertext model. Now we wanted to collect inputs that went beyond clicks to other links to other pages. We wanted input fields and buttons and pop-ups and all of that other rich collection of user interface controls that we got used to in our graphical user interfaces. For a brief, fairly unpleasant to be honest, period, we accomplished that by still sending requests back to the web server. So what we had at that point was still a page-driven request-response model. The browser interpreted relatively simple code in the form of HTML and sent that back and forth between the client and server. In this process, there's no real processing going on the page itself. The browser is an interpreter of HTML and running in a local process on your computer. But the page itself is just a dead thing, really. It's just the code that tells the browser what to paint on the screen. We cheated to get around this with CGI and other techniques, but that's really what was going on. The page wasn't really code at all, any more than text in a document is really code. With JavaScript, the DOM, Dynamic HTML and Ajax, we take a huge step forwards in terms of what we can do, and now we can run programs in the page itself. We have a new place for logic to exist. It's a very useful place because it's so close to the user. An HTML browser alone represents basic client-server communications. JavaScript gave us access to genuinely distributed programming. Some things should be decided on a server close to the data, perhaps using more resources than a user will have necessarily at their disposal. Other things are best done close to the user to give them instant, or at least near instant, feedback and control. Now we have the ability and freedom to decide where to put behaviour, based on the best place for that behaviour, rather than because of some arbitrary technical constraints. There are lots of things to be sniffy about in JavaScript. I confess there are lots of things that I don't like very much about it. Lots of people say that JavaScript is easy to learn, but I don't really agree. It's easy to start, sure, but it's pretty horrible to learn. But it does sit in this valuable, essential place right next to the user. And as a result, it allows us to do things that would be impossible if we had to permanently bounce data back and forth between page and server. The browser wars continued in different forms for a while, but through efforts to standardize and moves in the browser market, compatibility is now largely not a big problem anymore. JavaScript played a significant role in achieving that. The next step for JavaScript was more social than technical, in my opinion. That is, the migration from the page to the server. In JavaScript circles, this is seen as a hugely significant step, and it probably is, but not really from a technical point of view. It doesn't really change what you can do. I'm not even sure that it makes things significantly easy having JavaScript on both sides of the communication divide. What it does is that it saves people writing front-end code from needing to learn another language. This is an advantage, but it's more of a social advantage than a technical one. I guess my point here is that if JavaScript hadn't been the language in the web page, I seriously doubt that Node.js would have taken off in the way that it did. The huge deal here, the technical revolution that has propelled JavaScript to be regularly called the most popular programming language in the world then, is that it exploits a vitally important platform that no other language has really realistic access to, the web page. At one level, that may sound like a trite, obvious statement. Of course JavaScript is a child of the web. But I think it also says something a bit deeper and a bit more interesting about design and programming models in general. JavaScript is an easy language to knock. Even its inventor wanted to write something else originally. Brendan wanted to implement scheme in the browser, remember? JavaScript has quirks and in some ways lacks the kind of patterns and direction that helps to guide programmers to write better code. But it is the most popular language because it was in the right place to solve a very real problem. JavaScript helped to establish a workable programming model that tackles a genuinely difficult problem, how to handle distributed programming. Millions of programmers rely on this programming model every day, probably without thinking too much about it. And that programming model does something that lots of others struggle to achieve. What we're talking about here is dealing with distributed concurrent systems. The page is doing things in parallel with the server doing lots of others. Periodically, they synchronize their state to keep their respective pictures of the world up to date with one another. This sort of choreography isn't a simple thing to do well. Information is changing in multiple places at the same time. Get this kind of thing wrong and your system is trashed. But the programming model that has evolved over time is simple enough for beginner programmers to use it and flexible enough to solve most problems that we need it to solve. And of vital importance, it's there at the fingertips of every programmer inside every web browser. I think that underneath this is a pretty fundamental design idea for distributed systems. Things are easier if you put code close to where it's needed. And that's one of those ideas that goes well beyond just JavaScript. I wonder if WebAssembly will free up access to other forms of code in the page. It may. But for now, warts and all, JavaScript is at the heart of code in the page. 98% of web pages contain JavaScript. And as a result, there's not much web development going on without it. Thank you very much for watching, and if you enjoy my stuff, please consider supporting our work on this channel by joining our Patreon community. Thank you.